Imagine signing up for an experiment that sounds almost boring. You step into a room. The door shuts behind you. No windows. No cracks in the walls. No faint glow sneaking in from underneath the door. Nothing. Not one photon reaches your eyes. The first day is uneventful. You chat with researchers through a microphone. You eat when food arrives. You sleep when you're tired. That's it. No panic. No mystery. No dramatic breakdown. Then the days start stacking up. A week passes. Then another. And somewhere around week 3, things get strange. You start noticing bursts of color floating through the darkness. Fleeting shapes. Movement in the corner of your vision. Faces that seem to appear and vanish before you can focus on them. Light where there shouldn't be any light at all. The easy explanation is obvious. You've lost your mind. Except, that's not what happened. Researchers studying sensory deprivation kept running into the same unsettling pattern. When the outside world stops sending information, the brain doesn't sit quietly and wait. It gets to work. Not because it's malfunctioning, because it's doing exactly what it evolved to do. And that leads to a question that's harder to ignore than it first sounds. If total darkness can make you see things that don't exist, then how much of what you call reality was your brain constructing all along? Darkness doesn't take reality away. It exposes it. To make sense of that, we need to stop thinking about vision the way most people do. Most of us picture the brain as something like a camera. Light goes in. Reality comes out. End of story. The problem is that your brain doesn't actually work that way. Researchers estimate that the human brain uses roughly 20% of the body's energy despite accounting for only a small portion of its mass. And it isn't spending that energy passively waiting for information to arrive. It's constantly making predictions. Predictions about where objects are. Predictions about what sounds mean. Predictions about danger, opportunity, movement. Every second. Every minute. Every day. Your brain is not a recorder. It's a forecasting machine. Now imagine removing one of the largest streams of information it relies on. No sunrise. No shadows moving across the ground. No gradual shift from morning to afternoon. No visual proof that the world is still sitting where you left it. The incoming data disappears. The prediction engine doesn't. And that's where things get interesting. Because the brain can tolerate being wrong. What it struggles with is having nothing to work with. Not certainty. Not precision. Information. That's what it craves. So when darkness removes the data, the brain starts filling the empty spaces itself. Wait, that means the scariest part of total darkness isn't what gets taken away. It's what your brain begins adding. The brain fears missing information more than being wrong. To understand why darkness gets such a powerful grip on us, you have to go back to the world that shaped the human mind in the first place. Not cities. Not screens. Not electric light. Sunrise. Sunset. For roughly 300,000 years, Homo sapiens lived inside a rhythm so reliable that it became part of us. Light arrived. Light faded. Light returned. Again. And again. And again. Imagine being born into a world where the position of the sun dictated almost everything. When you traveled. When you hunted. When you rested. When you stayed alert because something dangerous might be hiding nearby. There were no clocks hanging on walls. No watches. No calendars. There was light. And over countless generations, your ancestors learned to trust it. Fossil records suggest that our brains evolved alongside these repeating cycles. Over time, light became more than illumination. It became information. Information about time. Information about safety. Information about opportunity. When the sun rose, one set of behaviors made sense. When darkness arrived, another set took over. Hormones shifted. Body temperature adjusted. Attention moved with them. Everything synchronized. Not just the body. The mind, too. And that's the part that's easy to overlook. Human consciousness didn't emerge in a vacuum. It emerged in a world that delivered the same fundamental signal every 24 hours. Light outside. Order inside. Darkness outside. Uncertainty inside. After hundreds of thousands of years, the brain stopped treating those signals as optional. They became foundational. Like gravity. Like breathing. Like reality itself. Human consciousness evolved inside a world synchronized by light. In 1962, a young French geologist named Michel Siffre decided to do something most people would never willingly attempt. He removed himself from time. Not metaphorically. Literally. His laboratory wasn't a research facility packed with equipment. It was a cave. Deep underground, cut off from sunlight, clocks, calendars, and every normal clue that tells you a day has passed. At first, life felt surprisingly ordinary. He ate when he was hungry. He slept when he felt tired. He woke up when his body felt ready. Simple. Nothing dramatic. Nothing cinematic. But then the weeks rolled by, and something started slipping. His sense of time began drifting away from reality. Researchers would contact him and ask how long he thought he'd been underground. Again and again, he got it wrong. Not by a few minutes. Not even by an hour. Sometimes by far more. His internal calendar was slowly coming apart. And here's the unsettling part. Michel didn't feel lost. He felt normal. That's what makes the story so fascinating. When your perception of time starts breaking down, you don't necessarily experience it as a breakdown. You simply begin living inside a different version of reality. Later studies found that without natural light, human sleep-wake cycles often stretch beyond 24 hours. In some cases, significantly beyond. The brain keeps counting. It just loses the measuring stick. Imagine reading a book while the size of every page quietly changes. The story is still there. The words still make sense. But your ability to judge scale disappears. That's what happened underground. Not confusion. Drift. Not chaos. Distortion. The lesson wasn't that humans need clocks. Clocks came later. Light came first. Without light, the brain loses its ruler for measuring time. Now imagine the darkness doesn't end. Not after a few days. Not after a week. It keeps going. And by the second and third week, another system begins to unravel. Your body runs on dozens of biological rhythms. Researchers call them circadian rhythms, from a Latin phrase that roughly means about a day. About a day. Not exactly a day. And that distinction matters. Your body temperature follows these rhythms. Your hormones follow them. Your sleep follows them. Your alertness follows them. Under normal conditions, sunlight acts like a daily reset signal. Every morning, the system gets corrected. A small adjustment. A reminder. A synchronization cue. But take that cue away, and the different parts of the system begin drifting out of alignment. Melatonin can rise at unusual times. Cortisol can peak when you don't expect it. Sleep shows up when it wants. Wakefulness does the same. It's almost as if different parts of the body stop reading from the same script. One system says it's time to sleep. Another insists it's time to stay awake. One says morning. Another says night. Order becomes disagreement. Researchers studying prolonged darkness have observed that people can lose confidence in one of the simplest judgments imaginable, whether they should be asleep or awake. Think about how strange that is. You know where you are. You know who you are. But you stop knowing when you are. Wait, that's a far bigger loss than it sounds. Because your experience of reality depends on sequence. Before and after. Morning and evening. Yesterday and tomorrow. Remove those anchors and consciousness starts to drift. Your body is not a clock. It's a clock that needs resetting every day. Then we arrive at the phenomenon that neuroscientists find most fascinating of all. The brain starts filling in the blanks. Researchers studying sensory deprivation noticed the same reports appearing over and over. People saw flashes of light. People heard voices. People sensed someone standing nearby. Not because something was there. Because nothing was there. At first, that sounds backwards. If information stops coming in, shouldn't the brain become quieter? Shouldn't darkness create emptiness? Turns out, no. The visual system doesn't shut down just because visual input disappears. Neural networks continue firing. Predictions keep being generated. The machinery stays active. Imagine asking an artificial intelligence to keep predicting forever while slowly removing the information it depends on. It doesn't stop. It improvises. And in a surprisingly important way, your brain does something similar. Not perfect prediction. Constructed prediction. Not observation. Generation. This points toward one of the most profound ideas in modern neuroscience. Your brain isn't sitting there waiting for reality to arrive. It's constantly generating a model of reality and then checking that model against incoming evidence. Moment after moment. Prediction after prediction. Correction after correction. But when the incoming evidence fades away, those predictions gain more freedom. A face. A voice. A movement. A story. If you're still with me, subscribe, because what's coming next changes the way you'll think about your own mind. Hallucinations are usually treated as proof that the brain has failed. The truth may be far stranger than that. Hallucinations are evidence that the brain never stopped doing its job. Reality doesn't arrive fully assembled. Reality is negotiated. Reality is revised. Reality is generated. 9:30 to 10:30. But before we lock in that conclusion, there's a wrinkle. A pretty important one. Because if darkness alone were responsible for all of this, then everyone should react to it in roughly the same way, right? Not exactly. Researchers have found that people who were born blind often don't experience visual hallucinations in the same way as people who once had sight. And that detail changes everything. Think about it for a second. Two people can enter the same environment, the same darkness, the same absence of visual information, yet their brains may respond differently. Why? Because the brain isn't just reacting to what's missing. It's reacting to what it expected to find. That's a completely different idea. Some people adapt to sensory deprivation better than researchers initially predicted. Others begin experiencing distortions much sooner. So the critical variable isn't always the darkness itself. It's history. Years of accumulated experiences. Years of learned patterns. Years of expectations about how reality is supposed to behave. Wait, maybe perception isn't built from the outside in. Maybe it's built from the inside out. Your brain isn't comparing reality against nothing. It's comparing reality against prediction, not darkness versus light, expectation versus absence. The brain doesn't react to darkness itself. It reacts to missing expectations. 10:30 to 12 o'clock. And once you understand that, the entire story starts looking different. Most people think humans need light for a simple reason. To see. That's true. But it's only part of the story. Because light isn't just helping you observe the world. It's helping your brain stay synchronized with it. For centuries, we've treated vision like a window. Light enters, information arrives, reality becomes visible, clean, simple, intuitive. But modern neuroscience suggests something deeper is happening beneath the surface. Light functions as one of the primary calibration signals for the human nervous system. Every sunrise provides information. Every sunset provides information. Every shifting shadow provides information. Not only to your eyes, to your entire biological operating system. Your sleep relies on it. Your hormones rely on it. Your sense of timing relies on it. Even your emotional rhythms are influenced by it. Take away that signal for long enough, and the system doesn't instantly collapse. It drifts, quietly at first, then more noticeably, like musicians trying to perform without hearing the same beat, like sailors navigating without a common star, like clocks ticking independently with no mechanism keeping them aligned. The result isn't immediate chaos. It's gradual separation, piece by piece, system by system. And that's why prolonged darkness feels so strange. Not because reality vanishes, because the systems that organize reality begin losing synchronization. Here's the deeper answer we've been circling the entire time. We do not use light merely to see the world. We use light to keep reality stable. And when that stability weakens, something remarkable becomes visible. Reality isn't passively received. Reality is actively maintained. 12 to 13:30. At this point, it would be easy to think this story belongs somewhere far away. In underground caves, in sensory deprivation chambers, in extreme scientific experiments. But it doesn't. It belongs much closer to home. It belongs to you. Because the same brain that struggled in total darkness is the same brain reading these words right now. Every night you stay awake beneath glowing screens. Every week spent almost entirely indoors. Every morning when natural sunlight never quite reaches your eyes. Tiny shifts. Subtle shifts. But shifts all the same. And remember what we've discovered. Your brain evolved expecting signals. It evolved expecting cycles. It evolved expecting light. When those signals become distorted, the effects don't always appear as dramatic visions or hallucinations. Sometimes they arrive wearing ordinary clothes. Trouble focusing. Trouble sleeping. A lingering feeling that something is slightly out of sync. Not weakness. Mismatch. Not laziness. Miscalibration. Not a personal failure. A signal problem. Wait, that's a distinction worth holding on to. Because people often blame themselves for experiences that may partly originate from ancient biological systems trying to operate with incomplete instructions. Deep inside your skull, mechanisms shaped over hundreds of thousands of years are still asking the same questions they always have. Where am I? When am I? What happens next? Every day your brain builds reality. Every day it revises reality. Every day it negotiates reality. The battle between reality and illusion isn't reserved for total darkness. It's happening inside your head every single day. 1330 to 1500 hours. Now think back to the man who stepped into that lightless room. For days, there was nothing. Then weeks passed, and eventually the colors arrived. The shapes arrived. The impossible arrived. It's tempting to look at that moment and call it a malfunction, a glitch in the system, a brain gone off course. But maybe that's the wrong interpretation. Maybe what he experienced wasn't a failure. Maybe it was a confession. Because the most surprising thing hidden inside total darkness is not that the brain can create illusions. It's that the brain is always creating. Normally, reality pushes back. Normally, incoming information keeps correcting the model. Normally, evidence keeps the construction anchored. But in darkness, those corrections fade. And for a brief moment, you get to see the machinery itself, the hidden process, the secret engine. The brain doesn't discover reality. It negotiates it. The mind is not a mirror. It's a model. Perception is controlled hallucination constrained by evidence. Strange ideas. Yet they explain more than they first appear to. Because light was never just a tool for seeing. It was a tool for alignment. A way for the brain to keep its internal world synchronized with the external one. And when you zoom out far enough, the whole story becomes almost poetic. On a small planet circling an ordinary star, among billions of stars scattered across an unimaginably large universe, human consciousness remains tethered to tiny streams of light that have guided our species for hundreds of thousands of years. Reality is not found. It is maintained. The light was never outside you. It was guiding the world inside. If you enjoyed this journey into the hidden machinery of the human mind, subscribe.